Hello, everyone. We are going to look at acceleration today. So if you did not meet mastery on your acceleration test, or if you just didn't do quite as well as you wanted to, you're feeling like you do not know everything that you need to know for acceleration, then you can go through this video, write down everything that I write down so you have some better, more condensed notes. So you have that in the future for any other tests that you might be taking. So let's look at our handout for our intervention for acceleration. Okay, so this is the condensed notes for acceleration. So the first thing we have here is our definition. So a change in the velocity of an object over a certain period of time. Okay, so remember that velocity is in meters per second. And that velocity includes direction. So north, south, east, west, up, down, back, forwards, whatever it is, as long as it includes a direction. Okay, so then we have the acceleration formula. So remember that A stands for acceleration. Acceleration equals the final velocity, VF, minus the initial velocity. Okay, so remember that the final velocity is the end, how fast it's going at the end, and the initial velocity is how fast it's going at the start. Okay, and then of course we have the time, t, that we are dividing by. Okay, a lot of people are struggling maybe just with the format here. So this line does mean divide. So when you're putting this into your calculator, you're going to hit that divide button anytime you see that line. Okay, so we're going to do the final velocity minus the initial velocity first, hit enter, get that answer, then hit the divide button and put your time in there. Okay, so that's how this formula works. Okay, so we're going to start off with the A. Remember that A is acceleration. And the acceleration is measured in meters per second squared, or it can be kilometers per hour squared. So the important thing for the units for acceleration is this squared right here for the time. I'm sorry, for the time. Okay, so you're looking for that squared. If you see that squared, then you know that it is going to be acceleration. Okay, so make sure we're looking for those squares. And that's how we tell the difference between acceleration and our velocities. Okay, so velocity, if you look, there's no squared anywhere for velocity. We just have our single unit of time. Okay, so the VF is the final velocity. And remember, that is the ending speed. And the VI is the initial velocity. And this is your starting speed. So that's important for us to know. Okay, and again, it's measured in meters per second. It could be measured in kilometers per hour. It could be measured in miles per hour, but making sure that there's no squares there. Okay, we feeling good about that? Okay, so that's the basics of our formula. And then of course, T over here is for time. I think we have that pretty well established from our other formulas that we've been working on throughout this course. Okay, so let's look now at the bottom half of this worksheet. Okay, so we're gonna look at some concept understandings. Okay, so whenever we have a positive acceleration, this means that it is speeding up. Okay, so the velocity is increasing. Okay, so it's getting faster and faster and faster. So that's for positive. For negative, our negative acceleration means that it's slowing down. Okay, so the velocity here is decreasing. We do have another word that means negative acceleration, and that's deceleration. Okay, so that's something important for us to remember. Okay, another tricky point is when something is at rest. Okay, if it's at rest or it comes to a stop, okay, that means that the velocity is going to be 0. Okay, so either 0 meters per second or kilometers per hour, miles per hour, whatever it is, the important thing is that you remember it is 0. So if it's at stop, if it's at rest, that means it's not moving. Okay, so if it's at rest or it's at a stop, it comes to a stop, it starts at rest, whatever it is, it's 0 meters per second. So this can either be for the VF or it can be for the VI. The initial or the starting speed velocity can be 0. Okay, and that's going to help determine whether we're going to have a positive acceleration or a negative acceleration, depending on whether it's starting, VI is 0, or if it's ending, the VF is at 0. Okay, so the next thing here is 3 ways that acceleration can occur. Acceleration occurs when an object speeds up. So it gets faster, it slows down, or if it changes its direction. Okay. So we talked about a car going around a corner. If the car is going around a corner, it keeps its same velocity, but because it has changed direction, we consider that being acceleration. Okay, same idea with a merry-go-round or a carousel or even the planets in our solar system. Even though they are at a constant speed, because they are going in a circle, they're constantly changing directions. So we know that the planets that are going around our sun are always changing directions. Okay, so that means they have acceleration at all times. Okay, so let's look at one example problem before we wrap up this intervention lesson. Okay, so this example says a spaceship accelerates from 12 meters per second to 44 meters per second in 3 seconds. What is the average acceleration? Okay, so we are looking for acceleration. We want to know what is that acceleration. So the first thing we have to figure out is for these 2 speeds or these 2 velocities, where is it starting at and where is it ending at? So the way this one is worded, the first one is going to be the initial velocity. It starts at 12 meters per second and it goes up to the final velocity of 44 meters per second. Okay, so we can fill in what's given to us in our word problem here. So the final velocity is 44 meters per second. And the initial velocity is 12 meters per second. And of course, seconds is the time. So T right here is going to be 3 seconds. Now, our formula, we're using our base formula, acceleration equals final velocity minus initial velocity, and all of that divided by the time. Okay, so now we want to show our work. So we're going to take these numbers, plug them into here, and write it down. So the final velocity is 44 meters per second. We're subtracting that, 12 meters per second, and all of that's divided by the time of 3 seconds. Okay, so when I work this out, the first thing I want to do is subtract. So subtract first. Okay, so we're going to do 44 minus 12. So that gives me 32 meters per second. And then I'm going to divide that by 3 seconds. Okay, so remember this line right here means divide. So I'm going to use that divide button on my calculator. So I'm going to do 32 meters per second divided by, and then 3. Okay, so whatever's on top goes in the calculator first. So top goes first. Okay, so we're going to do 32 divided by 3, and we're going to get 10.6 repeating. So I'm going to round that up to 10.7, and then I need the units. So because this is meters per second, this is meters per second, and this is seconds, I'm going to use meters per second squared. Okay, don't forget that squared because that's what makes it acceleration. All right, guys, I hope this has helped you understand acceleration a little better. Take a minute, finish writing everything out, review over it, and good luck on your retest. Have a great day.